Cool. Making sure we're recording. Um,
We are, yes.
we are perfect. Thank you so much for confirming. All right, welcome everyone. It's a pleasure seeing you all in person online. We've been going through this journey of agents with Llama Index. So it's part of multiple series. We have this Dune theme here, part 1, part 2. So a little bit about us. We're part of Data Community DC, a larger group of communities that the goal is to democratize knowledge, share insights, support each other, build something cool together, and have fun, right? That's the most important. So check us out, dc2.org, and you can learn more about the diversity code that we have there. This is some of the meetups that we have there. So data science, database, data wranglers, generative AI, deep learning adventures, statistical, our GAVIs, data education, statistical programming, and a couple more, I think. Yeah. So thank you to our Sports Rotational Labs and Excella for hosting and food today. So thank you so much. Appreciate it. Yeah, join us on Slack and the newsletter. And team does a great job here of sharing the updates. Cool. So all the sessions, in case you're joining us for the first time or you've heard about us, we started this journey a year ago on generative AI. So it's been a while. Let me zoom in a little bit. So the latest one was a couple of months ago, 4 months ago on Llama Index. So we did a couple of events. So we did part 1 and part 2. And today we're going to talk about part 3 of these events, right? So on Meetup, again, you can find us. And today we'll talk about this agentic document workflows. What is that really? How is it different from what we talked about earlier? And, what is so different about it? Cool. This is based on this course from Deep Learning AI. Deep Learning AI has, if you filter for, so I'm going to zoom in, zoom out a lot, just so that you know where I'm pointing. So in Llama Index here, Deep Learning AI, if you sort by oldest, we started with building and evaluating RAG applications. David here presented a session on it that was inspired by this and other material. We did a JavaScript one that was fun. Usually do Python, but it was good to do some JavaScript. And part 1 that was. Part 2 was agentic RAG, simple basic application of RAG using Python. And this is the latest until Deep Learning AI releases another one, hopefully very soon. Every time I log in, there's a new course, so we're trying to keep up. Cool. So what we're going to do in this course is, I think there's a great image in the course that describes really, really well what we're going to do, but we're going to move a little bit from just basic RAG and text and simple LLM calls to building actual workflows. So you'll see that we'll have some logic, we'll do some reasoning, we'll have loops, and some cool applications. And what I mean by cool applications, let me skip ahead a little bit. Well, we'll have this resume here, right? It's been challenging for many of us, this couple of years. So if you're looking for a new job, this is a fictitious resume, but you could try an actual resume. Here it has some projects, has some certifications, languages, and so forth, and a fictitious big tech company job application form. It's just a form, could be a website. So it has some questions, right? It has name, phone number, portfolio, and then some questions. Describe why you're a good fit for this position, and do you have any experience in specific technology? So the goal is now to parse this application form and parse our resume, and then ask an LLM, hey, how do I answer this? How do I answer this? How do I answer this? Fill it in for me. That's number 1 step. And number 2, more advanced, would be, okay, let's have a human in the loop now, that for every question, there's a human saying yes or no, I like your answer, or can you improve it, or can you give me, can you emphasize on this skill set, or can you emphasize more on my front-end experience, and so forth. So that's the application I'm going to be building towards. Cool. So the nuance here, the new introduction is this workflow, this agent workflow. And on the course, there's this diagram here that does a great job describing it. But basically, it's a combination of RAG, documents, and also some kind of structured manipulation of data, right? So we're going to input a document. In this case, could be a resume. We'll identify what tasks need to be performed. This is part of the workflow. We will need to retrieve the relevant materials from our RAG system. So we'll have a RAG knowledge base, and then we'll output something in a structured format that this workflow can take, or some other workflow can take as the next step. So some examples could be, let's see here, could be a contract review. Maybe you have a contract, right? And this is actually something that I might use. You might have your regulatory requirements, right? If you have a regulations, if you have a policy, this might be a RAG. And then your document could be your contract. And then the goal would be, does this contract violate or meet all my requirements? Right, you can have specific set clauses. Or the other one is maybe you have your product catalog with a lot of information, with IDs and things like that. And then you get an invoice just by name, maybe. So you don't have any ID, so you don't have any metadata. So then the goal would be to use this RAG and the invoice and find the relevant information in this product catalog. So for example, let's say 32-inch TV, microwave, whatever you're selling, right? And then in this RAG, you can have, oh, this is the product ID, this is where you can find it, and more information. Cool. And then the app could be, an actual standardized invoice. So let's kick it off with this workflow. And if this first notebook is, I think, the steepest learning curve. So if we pass this, this milestone, we're good. Nothing new, nothing fancy. It's just new. Nothing crazy. It's just not something you see in RAG or GenAI. So it's a new construct from Llama Index. Cool. So I think it's best if we show and then me describing. So I don't have any fancy methods here that I'm importing, just some API keys we're going to use for LLMs. And we're going to display some HTML content. That's actually where the workflow will be displayed. So we'll take a look at that. Let me hide this. There you go. Information. Cool. So let's create a simple workflow. This is from this Llama Index Core workflow. We'll have a couple of things. We'll have something called a start event, a stop event, a workflow, a step, a context. And you're asking, okay, what are these? Think of them as, so like event-driven, right? So we're doing something event-driven, so we need some kind of way of telling our workflows what is happening. In the end of the day, these are Python classes, nothing fancy. They have their own methods, they have their own variables. So in here, I'm extending the workflow class. I'm creating my own, and I'm just defining a very simple step called my step. It takes as input this default start event class that is triggered every time you run the workflow, and it emits or it outputs a special event called stop event. So the start and stop, as you can tell, are created by default by Llama Index, and they are generated when you start the workflow. So you'll see here how this works. So I'm creating an instance of this workflow class. I'll wait 10 seconds in case this needs some time to run. I won't be printing any information here a lot, so I'll set verbose to false. And all of those workflows, by the way, are running asynchronously. So you'll see a lot of await and async when I do this in Python. So what I'm doing here is printing hello world, nothing crazy, but in the backend, what is happening is, let me do this. There you go. Let me display the HTML. So I have this, let me rearrange it. I have this start event, right? It's cool, right? This start event is emitted every time I hit the run workflow. And then in my class, I accept, if you remember, I expect a start event. When I do that, do something here. In this case, I'm not doing much. I'm just emitting a stop event and passing it an argument. So nothing crazy, right? Very simple. Oops. A very simple. Yeah, I zoomed out too much. Let me display it again. There it is. Cool. Let's do a little bit something more advanced. Let's create our own events. That's the beauty of this workflow. So you can create your own custom events. So in this case, a class that inherits from event class and just has a string a variable, first output and second output. Let's do that. And let's look at, I would say let's look at this first. I think that will help us understand the code better. So what are we doing here? All right, things around a little bit. So I have the start event, I rank my workflow, it calls a function called step one that emits an event called first event. This function called step two expects the first event. that emits a second event. This function called step2. So blue is function and green is events or messages in other contexts, right? So basically just an input output. So input, process, output, process, output, process, output, and then done, right? So let's see how that looks like in code. So I have my events, my first event and second event, and then the first method and the asynchronous method accept the start event. That's the default when you hit run. That's what the workflow emits. It does something. In this case, it just prints the output of whatever is passed. And when we call it, actually, we call it with start workflow. So environment dot first input is this string here, start the workflow. So all it does is creates another event, first step complete. And if you notice first step complete, my second method accepts that. It does something, it emits a second event. It does something, it emits a stop event, and that stop event just completes the workflow. Okay, so nothing crazy. Yeah, absolutely.
So when you've got like a first event is the whatever the output. Can I see the picture maybe?
Yeah.
Sorry, with the picture. Oh,
let me find it.
okay. So
Here.
first event emits a step two or has like a step two attribute. Is the first event like an object and the step two is like an attribute? Because you were just saying that the event type for first event was an input to second event, but not step two being an input to second event.
So the blue ones are methods, think of it that, or steps as they're called in this workflow. This could be an input or output. In this case, it's output of step one. It so happens that it's also the input to step two. So it's an event, a class, and as a class, it has its own attributes. In this case, we're just storing a simple string within it. So a message, so message, method, message, method, message, method.
Okay.
Yeah, message. Yeah. Cool. Let's create some loops, right? There's not much happening here with just a straight processing of events. You can do that, back to back. So let's create a special event. There's nothing special about this. So we'll naming it loop event, and we'll see how do we create the loop here. So in my workflow now, the difference is my step one is accepting or expecting a start event. It will get triggered when a start event is introduced in the workflow, or my special event called loop event. So it's triggered based on two triggers, either start event or loop event, and also emits something called first event or again loop event. Again, I mean, this will be easier to see when we create the visualization. And then some logic. In this case, the logic is just to flip a coin, but the logic could be I found information, I didn't find information, whatever my business logic might be. Okay, so in this case, we're flipping a coin. If it's 0, we'll create a loop event. If it's 1, we emit a first event. And then if we do that, we get out of the loop and we do the second step and then finally the third step. So let's look at the graph for this. Okay, actually, let's run it. So we're running it and looks like the first time good thing happened. So it actually didn't go through the loop. It did the first step, the second step, no work complete. Let's run it again. Good thing happened. Good thing happened. There you go. But we flip the coin 0, 0, 0, 0, 0, and then finally flip a coin 1, and then we get out of the loop. What does this look like? Ideas? Let's see any. Zoom out a little bit. There you go. Let me move this around. So we have in step one can emit either a first event or a loop event based on a flipping of the coin. 50% chance we end up in loop event, 50% chance we have on first event. If we exit the loop, we cannot come back and we finish our workflow. Yeah. So nothing special there. Cool. So we have simple execution, we have loops. Now let's do branching based on some logic, basic, programming type of concept. So let's do a few events. So we have something to work with, building blocks. So we have a 1 event, a 2 event, all they're containing is just a message string, as you can tell. B1 event, B2 event. This is my building blocks. Now let me look at the workflow first, so that the code makes more sense. So let's see here. So I have a start event. Actually, this might be easier to look here because it's symmetric. There you go. Down here. There you go. Ah, you see the symmetry, right? So sensitive. All right. So I have a start event, and now I have a branch. Both my start method creates two events, and they are run in parallel. So I might do, okay, parse my document 1, parse my document 2, do whatever you need to do, and then in the end, gather their output, combine them, analyze them, whatever, end.
So they're simultaneous. It's not like a decision tree where it's one or the other. They're simultaneous.
It's simultaneous. It's simultaneous. Yeah, that's why we have this as sync, and that's why we're going to see later that okay, it will look like a MapReduce type of flow where this is parallel, and depending on the complexity, the hardware, the software, this might take some time to run. Okay, so sorry, let's look at the code. It's so cool to look at the graph that you forget the code. All right, so the start now accepts the start, and it can emit either A1 or B1. So let's go to the graph. The start accepts the start event, and it can emit a B1 or an A1. And then each one of them now, let's say A1, what does A1 do? So we flip a coin, and we can go to either 1 or 2. Sorry, this is a branching. We're not doing concurrent here, but in the next one we'll do concurrent. Yeah. So we pick one branch and we execute it. And then if we pick the A1 calls A2, and A2 calls stop event. Similar with B1. B1 calls B2, and B2 calls stop event. So yeah, I want to clarify. This is one branch at a time. And then the concurrent one is this execution. For this, we're gonna need some kind of memory, because we need somehow to share information between these two processes. We need some kind of storage, and that's the concept of this context here. It's a form of shared memory available to every step in the workflow. Okay, so what we're gonna do here is we'll have this workflow, and we'll just have one event. And what it does is it takes our memory, it takes our start event, it sends this two event with different inputs. So it says query 1, query 2, query 3. And then here is where we can run this in parallel. We can do all 4 events in parallel. But here now we expect the same memory as well as a step 2 event. In this case, I'm emitting 3 of them. And what this is doing is saying running slow query and the name of the query. It's sleeping for 1 to 5 seconds, and then returning a stop event. So what that is doing is it's running a slow query, it's running query 1, query 2, query 3. The first query that exits, the fastest one, in this case happened to be query 1. Let's run it again. It could be query 3. It hits a stop event. The other 2 queries didn't get to complete. We just stop. It's basically a race. So we do these queries, whichever completes first, we exit out of the flow. Maybe we don't want that. Maybe we want to actually wait for all the events to be completed. So let's collect them. And that's the method we're going to use here, this collect events. So we have an event called step 3. Similarly, we have our start. We're going to issue 3 queries at the same time, 1, 2, 3. We're going to wait for a second or two. We're going to emit a event 3. And here's so easier to see. And when we do that, step 3 now will take the input, the step 3 event, and it will wait. This collect events is actually waiting for step 3 type events, and specifically 3 of them. So you can say, okay, I ran 3 queries. I expect 3 of them to be completed. If 1 is completed, the result will be none. If 2 are completed, the result will be none. If 3 are completed, all events, then we can go to the next step, which prints the results and emits a stop event. Okay, so let's look at what this looks like. So it's running query 1, query 2, query 3. Not all events received, maybe received 1, and then maybe second one, and then it received 3, 2, 1. And just to show you that this is concurrent, now it ended in 1, 2, 3. So the order doesn't really matter. They're happening concurrently.
So what was the parallel concurrent flow?
So the parallel, I didn't wait for them. I just exited on the first one output I got. This one I'm actually collecting. So it is parallel. It's just that I'm either waiting for all three or not. That's the only difference. This line here. Yeah. Cool. So yeah, this is similar to MapReduce. And then this is not just taking a step further where my events can be very different. Could be a complete step one complete, step B complete, step C, and so forth. Let's look at the graph. I think it's easier if you look at the graph. Okay. This is also symmetric kinda. So we have a start. The start can emit any of this event, right? So call LLM1, call LLM2, call LLM3. Then they run concurrently. They do something, they complete. And then step 3 is actually going to wait for all 3 of them, right? Step 3 is going to wait for all these 3 queries to be completed and then end the workflow. I know that's kind of hard to understand because there's no practical application, but the next notebook actually is going to do something more practical, you know? But these are the building blocks. Cool. All right, let's go something more. Okay, the last concept we'll introduce is this concept of streaming. And that's because we have large language models and you enter a query and then you might say, you know, generate me a paragraph of, you know, my favorite book. It might take a few seconds. We don't want the user to wait for the output. We want to stream any output that the large language model emits. So in this case, we want to have like just a better user experience. That's the concept of streaming. So we'll have different events, first, second, text event, a progress event. These are just names. And then in here now, we'll start with step 1 is happening. We'll emit the first event. And the first event, all it does is in step 2, we'll actually call this GPT-4o mini large language model. It's fast, it's affordable. And we'll ask it, please give me the first 50 words of this book, right, Moby Dick. So we'll do that. It will give me a generator. And then as I'm parsing through the generator, I'll write to this stream a text event. That's what I'm doing. And then the text event. And I'll create a, sorry, I'll show this in the output. And then when I'm done, I'll just emit a second event and that will say everything is done. So basically I'm streaming the output instead of running them one by one. And now the work, instead of just run, I have to have a for loop for this event streams because it's coming. I missed something. I think I missed this class. Yeah. Okay, so step 1 is happening, first 50 words, you know, and then workflow complete. So I looked at it. Yeah, so, you know, called me Ishmael some years ago. I don't know if it's exactly the same, right? I think so. Whenever I find myself, I think it missed the sentence or, yeah. So whenever I find myself, it's here. So I don't know. Maybe it was trained on like miss a sentence or they did that to protect the book. I don't know. So yeah, this is the workflows. Again, we're going to see them in the next notebook, more details, but these are the building blocks. If you got lost, it's okay. We're going to see it again in the next notebook with more practical applications. So far, so good. Online. Any questions, put them in the chat.
So is this sort of to replace the idea of threads?
It is similar. It's very similar. I used to, yeah, I love threads, by the way, and I used to do a lot of parallel programming, but yeah, it's similar to that. It's just not as advanced as threads. You don't have like semaphores, you don't have like parallel algorithms, mutual exclusion, things like that.
Going to that.
It's sort of going to that. It's to me, it's like a MapReduce for Gen AI, you know, like we had Hadoop. and you had multiple queries, run them in parallel, and then reduce them. It's similar to that.
So just Apache Airflow for.
For LLMs. Yeah. I mean, very early phase. Okay, 0.01 version. Very basic capabilities.
The folks at Prefect, which is sort of Airflow, the whole modern Airflow, they've actually built their own like agent workflow framework, sort of like context. Very, very similar problem space on you.
Cool. What we're gonna do now is look at some vector embeddings. Okay, so we looked at, if I go back to, where's my screen? If I go back here, all we did is add some input, do some workflow, create some output. There's no RAG here. So in this second notebook, we're gonna add RAG, just so that we know where we are. And we have, many options. We're gonna use this text embedding 3 small. It's like a new high-performing, affordable embedding model from OpenAI. That's what we're gonna use. All right. Let's zoom in. So adding the RAG. How do we do that? So we need some API keys, HTML to display some workflows, some asynchronous libraries because it's done in synchronously, and some API keys for OpenAI. You'll see this Llama Cloud. It's for parsing documents. We'll actually take a look at that. Cool. So there's this concept of Llama parse. It's this library that a Llama index has when you have rich documents like this, right? You have input, you have graphs, you have PDF, PowerPoints, whatever. How do you convert it into a machine readable format, right? Instead of you taking a look at this. So that's the goal of this Llama parse library, where you need an API key for it. It's free to get it, but I think they charge you if you use it more. And the goal is now you take a structured document and convert it to something like this, where now the numbers are from images, they're converted to text. So that's the point of this Llama parse. So let's see how we use it. From Llama parse, import Llama parse. We need an API key, some URL, the result type, we want it to be markdown. And we also want to guide a little bit this parser, right? So what is this? Because in the backend is an LLM, as you can imagine. There's a resume, gather related facts together and format it as bullet points with headers. And my resume is this one here. Okay. So let's parse it. And let's look at some of its documents. Maybe the second, it has multiple documents. Let's look at this one. So it says projects. So it's under page, I think, here, right? So it says echo track, chat flow, da-da-da. So this should be literally as it is. No retrieval here. You should be able to parse it as it is. Cool. Now, the other thing is to do the RAG, we actually need documents, which we have here, right? We went from PDF to documents. We need an embedding model, and then we need an index that uses this embedding model, embeds these documents, and then based on your query, gives you the right context. So basically, we need this index object to be able to query, to retrieve information, right? So we use this, we use our documents and this text embedding 3 small. And for LLM, we're going to use GPT-4o mini. And then SQuery engine just converts that index to a queryable object. So we'll use a GPT-4 mini. We're going to retrieve many documents in the backend. Top 5 are going to be retrieved here. And the question now is, what is the person's name and what's their most recent role? That's their name. Most recent role is senior full stack developer. So if you look here, full stack developer, senior full stack developer. Is that what it said? Yes, a tech flow. Okay, a tech flow. Cool. So basic RAG. Another cool thing to do with Llama index, you can store this index. Imagine you do this for multiple documents. You don't want to do this every time. So you can persist the index itself, the index data in disks. So that's what you're doing here. You're persisting it. And then later you can say, hey, do I have any stored indices in my disk? Yes, okay, retrieve it, restore it. If not, recreate it. So here I'm retrieving it from disk and I'm asking the same question. Cool. So we have RAG. Let's just add tools to it so we can have very simple version of agent, and we've seen this function tool and functional calling agents before. But all they do is they basically allow an LLM to access some tools. So one of my tools is this, or one of my methods is this query resume. It takes a string and outputs a string. I'll convert this to a tool. So it's very important that you specify the input, the output, as well as a doc string that shares a little bit what is this. So in this case, this answers questions about a specific resume. All it does is queries my index. That's what it does, the LLM in the backend. So this is a question about the specific resume we have on our database, and that's the user input query here, and then returns the response. Let's turn that into a function tool right here, resume tool. And now I can give it to my LLM. You have access to the resume tool. And then I can do something like, how many years of experience does this applicant have? It will call my query resume function with my query, and it will find 6 years. If you look here, that answer is somewhere here. Yeah. Be cool if the 6 wasn't there and had to do math, maybe based on years. Cool. So now let's add, this is RAG, it has nothing to do with workflows. How do we add it to a workflow? We'll just create up a setup step, which setups the query index. It submits a query event, it asks a question, and completes it. So start, stop, workflow event context. We have a query event, and the workflow here is, we have our stored index, we have an LLM, and we have our stored, the actual object. If we don't pass the resume as input, we're gonna create this message. Otherwise, we're gonna use this LLM. And then if we have the query engine in the disk, use it. Otherwise, we need to parse the data if this is the first time we do it. And this is how you do it. You do the llama parse again, use the embedding, and you persist it. At the end of the day, we don't query it. We just return that, we just emit this query event, and then the next method actually queries the LLM, right? So let's look at this. So we have our resume. Let's look at this. And the question is, where is the first place the applicant worked? And there's a company here. So let's go back here. Startup Hub, junior web developer, right? So it figured that out. So yeah, that was basically wrapping everything in a workflow. Nothing crazy here, but as you can see, there's a little bit of setup in, if this is the first time I'm doing it, if it's the second time I'm doing it, and so forth. Cool. So far, so good? Yeah. Okay.
So the difference, to be clear, I don't know if you go through this, but like this RAG workflow versus a standard workflow, you've got these variables at the top that are part of the class, the RAG workflow class, I assume.
Yeah, it's like class. It's a typical
Yeah.
class. Yeah. So these are my global variables.
And is the setup is also required as part of
The workflow?
RAG workflow has that.
Yeah, you need some kind of method, some kind of setup. Yeah. I mean, the flexibility is that you do something and then you meet an event. I think that's the difference here, that you can do something like this is a simple workflow, but you can do branching, you can do looping, you can do conditions, you can have human in the loop, you can do.
So that was what we asked. So the concurrent workflow and the parallel workflow.
Yep.
All work within the RAG workflow.
The RAG workflow, yeah.
Okay.
Otherwise, you have to implement them yourself, and
Yeah.
it's going to be tedious. Here's like a framework.
The example here, you're really not leveraging the workflow capabilities.
No, yeah.
Because you're doing the simplest thing.
Mm-hmm.
I mean, you could just code it up without a workflow.
Yeah.
Simplest case, but
Yeah, I have a wheel, it spins. Yeah, but now I'm gonna add a second wheel, I'm gonna steering wheel, and I'm gonna make a bike. Yeah, exactly. Okay, cool. All right, something more interesting. Let's go. So refresh this. Now let's go to the form side of this. So we spend a lot of time parsing resumes, right? Okay, great. We can do some RAG on resumes. Awesome. Now let's look at the other side of this, which is this application form. Somehow we need to parse this. We need to understand what it's asking. And then eventually we need to answer questions based on our resume, right? So let's parse the form first. Okay, and we'll use the same library here, llama parse. We need an LM for interacting with all this, some embeddings for storing indices, including resumes and forms. The workflow just to allow us to do this in an asynchronous way, things for displaying, asynchronously keys. So I'll create a parser, and this is an application form, create a list of all the fields that need to be filled in. Return a bulleted list of the fields only. So let's look at the result. And this is my application form PDF. Get it again, right? So it has name, email, LinkedIn, and then some questions here. All I need is the fields. Okay, let's print it. So I have name, email, LinkedIn, and then the questions, right? So I converted a PDF to a list of strings. That's all I did. Cool. So now LMs are good for converting, English to structure output, and then the opposite, structure output to English. So in this case, I need this to a little bit more structure. This is a bit, just a bulleted list. I need it as a JSON so I can programmatically work with it. So I'll use GPT-4o and ask, this is a parsed form, convert it to a JSON object in this form. And let's look at what that looks like. So I have the first name, last name, email, and then my questions, right? And let's print it, looks cleaner. Cool, so let's see now what we're gonna do. So first, in the last workflow, we had this, simple, right? Here we're gonna do is, we're gonna parse the form, so whatever the form might be. Let's say you pointed somewhere, this is my form, this is my job application form, parse it, and parse it, okay. Then the next one is, okay, how do I fill this form? So we need some kind of asking questions, like what is the answer to this field? So parsing it, getting it back to a text, and then okay, I have the fields now, but what is the answer to the fields? What is the answer to each question? That's why we have this ask question. And then the next step would be, how do I generate questions? I have the field, it's asking me how many years of experience do you have? Somehow I need to query my resume with how many years of experience do I have and find the answer. So this will be the second part. So parse the form, parse the resume, query the resume, answer the form questions. That's the workflow. Cool. So let's parse the form here. So let's
That's a question. Does it answer them all?
That's a good question. We will see. We will see. Yeah, we'll have a loop. Exactly. For each of the field, we'll have a loop. So in this case, let's do the resume first. This is similar to what we saw before, just parsing the resume and storing everything in an index. And then this is the new part. So this is the parse form part of it. So this is job application form, and then create a list of fields, create a JSON, and stop. And then the ask question, all it does is, this is a question about a specific resume we have in our database, whatever my query might be. So let's see, what are we asking here? We're giving both the resume and the application form. And let's see. Somewhere. Oh, this is from the form. This is not a question we asked. So let's generate this question, right? So we need this. Let's go together. So somewhere here, once we parsed, let me zoom in a little bit. Once we parse the form and the resume and the form, here somewhere, we'll need to query our index with a specific question, and then we need to say here in the application that you're giving a list of fields in application form and no, sorry. So this is the response for each question. Okay. So here, for each of where are we? So there's this concept of remember this context stores actual information. So what I'm doing in here is I'm storing them as query events, meaning these are messages that needs to be fulfilled. And what they are questions about our field. So I parse the document, I parse the form, and for each field that I see, I'm generating this query event that says, how would you answer this question about the candidate? And there's a field, and the field is one of the name, email, description, how many years of experience.
CTX, is that the shared memory context?
Yes. So I'm putting them in like a bullet form, like a message board. I'm saying, how would you answer this question? Green sticky note. How would you answer this question? Pink sticky note. And I have many of them. And now these are run synchronously. And then whenever I see a query event, here, all I do is I go to my RAG system and I pick one of them and I ask my RAG, how would you answer this question about the candidate? And the question could be name. You look at my vector store, it says, oh, name, Stephanie. Okay. How would you ask me this question about years of experience? Years of experience, it's mentioned, or I need to reset. How would you answer this question about phone number? Maybe it's missing. Yeah. So that's how I answer it. And then this fill an application, all it does is it waits for all my response events to be collected. So somebody collects all the answers, all of them. It just concatenates them into responses. So let's see what that looks like. So here's the parsing. So first name, it matched it with Sarah. Last name, it matched it with her last name, email, phone number not provided, right? That's cool. If you see here, I don't see any phone number. So that's cool. LinkedIn project portfolio. Keep this in mind. What is portfolio? Her portfolio is a website. But my LLM is saying includes notable projects such as EcoTrack and Chatflow. And those are actual EcoTrack. Somewhere here. Maybe in the projects. Yeah. It's actually listing her project as portfolio, which is not bad, right? It's not going to the website. And then graduation date, current job title, current employer, technical skills. Describe why you'd be a good fit for this position. Let's see what it's saying, right? Over 6 years of experience as a developer, experience in leading technical teams, architecting. So it's kind of dry, right? It's kind of like, it's trying. And then do you have 5 years of experience in React? Yes, over 6 years of experience in full stack development with specific expertise in React. So let's see. React. React is everywhere here. Yeah. All right, let's visualize this workflow. Okay. Zoom in a little bit. Okay, where are you? There you. Oops. There's a outer container and inner container. All right. So set up, parse the form, and then for each field in the form, I'll issue a query event. And then all that query event does is ingested by this ask question, which uses our index, our LLM from our resume, gets a response event, and then the fill application just expects them all. Yeah. So there was a lot here, but you see the goal is you need multiple building blocks, right? You need the form parser and the resume parser, and then for each field, this is I guess the meat of it. For each field, in your form, you need to issue an event that will be processed later. And what that means is that you'll query your RAG for this many fields. Yeah.
If you application, it shows a field application function. Field application.
The
You go fetch out. This function.
oh yeah, yeah.
Field application.
Fill application. Oh yeah. Fill application all it does is so it does two things. It has a response event, and that response event now has, so let's look at it, right? The response event has the query that that we added, and then the response. So in this case, it will have my input. This is a question about specific resume we have in our database, and then the query, which could be name. Any of this could be name, email, portfolio, degree, job title, and then the answer, because it's querying an LLM here, an answer response. That's the response event. And this fill application, it's not actually copy pasting and adding it in the form. It's just giving you as an output next to each other. So it's giving you this. Now, if you had a tool that says, okay, I have this, now how do I fill in this form based on this? You need to somehow call it, I don't know. I don't know, there's like a Word document, filler or PDF filler to actually copy paste it.
Produce the same answer if you want to.
For the ones where the question is kind of, the fields is very well defined, like these ones, I would say more or less yes. These ones, I would expect the answer to be different because it's like querying an LLM. Yeah.
And if you did not have explicitly 6+ years in the document itself, but rather just the dates, would it, without additional tooling, be able to calculate that? Is that within the realm of possibility?
Yeah, I think you need to guide it as, you need to say in your resume parser, if years of experience is not there, please calculate it. And then probably need to call a tool. Right, you need to.
I use it on one word because if you were to just plot the entire thing to a large context model, yeah, because it's getting the entire context, not just the search response places, like everything. Yeah.
Trusting LLM to accurate math is always questionable. So, but it might be good to add a step that's like extract the earliest relevant work experience date, and then just straighten up on that.
Yeah, we can also, let's see, I can ask something like, let's ask something that is not super straight, right? So let's look at maybe we can ask how many companies has this candidate worked, right? So it actually needs to count, right? So we have 1, 2, 3, right? Let's see if we'll get that. How many roles or does the applicant have? Did he have? Three roles, okay. Okay, come on.
What states? Cities.
What space? What field?
Cities or states that work in?
What city is the applicant from? Is that what you're asking?
I know, I'm saying, how many states did it work? I don't know, are they all?
Oh.
California? What-
Job locations.
job location?
How many states did, I think the applicant, I need to keep it.
Is it only California?
And for which ones? Huh? Uh-huh. States. Typo. 2 states, California, Nevada. True? San Jose, California? Oakland, San Francisco? Where's
I don't
Nevada?
see Nevada.
Come on.
Mitigate Nevada.
Where's Nevada?
Uh,
Aha.
Just guess.
What? Sorry.
Sarah Chin must be in,
Yeah, that's a good
the
question.
training data somewhere.
There's no Nevada.
There's a real Sarah Chin.
And I came from Nevada. I was in Vegas. So where's the? Is there a Nevada anywhere here? I don't see it. Do you?
Yeah.
Meetup? Aha. There you go. And V maybe? Environmental? But look at the cities. The cities are both in
Maybe there's a Oakland.
Oakland and Nevada. Pro. 2 states. And 1 location. No! No! You're doing worse. Okay. All right. Try it again. What is this? Gambling? All right. How many states? Aha.
I wonder if that changed.
Oh, no.
Wearing the badge.
Did this? Okay.
So one thing
Work in
you are
Nevada.
doing a chat here. So it's using, it has prior context about Nevada.
Aha. Okay, let me reset it.
Oh, look at that.
What happened?
Yeah, I'm sorry, I got that wrong.
I'm so, please dial again. Human. All right.
How it does on things that are both factual and subjective, like
Uh-huh.
if you ask, is this candidate a job offer?
Ooh. Okay. Is this applicant
I'm not sure what the criteria would be for that.
job offer?
But
And maybe
Give it
yeah,
a shot.
justify.
Based on his training data.
Has held 3 positions over a span of approximately 6 years, with each role lasting a significant amount of time. Career growth and development. Does not exhibit job hopping. Yeah, sorry, sir, no.
Ask them what should they improve on? in
Oh.
terms of-
Okay, now we're going to career advice.
Yeah.
We need an agent for that.
Really subjective.
$5.99 for that, right? What
Uh,
career advancement? Huh? Recommendation? Do you have for this applicant? Study Nevada, maybe.
You're generally on.
Whoa, right. This is 4 right? Leadership. Taking on more leadership roles such as project management, team
You lean forward.
advanced certification, emerging technologies, DevOps, cloud. Okay. Network, mentorship.
Coming out of the GPT menu.
Yeah.
Right?
So can you ask her what salary she should get?
Wow. What is a good salary range? Yeah. Should I put a state or no?
No, stay.
No state? Location, industry demand, experience.
Think of a range.
San Francisco. Makes sense. To the center still.
Okay. All right.
Now you ask if the candidate's fake.
Oh. Who am I? How do you know? I mean, is this real applicant? Is an AI applicant? However, determine if it's real applicant. Further verification would be necessary. Email, GitHub, LinkedIn.
There's so many.
That's like a governance related question.
Yeah.
Some potential guardrails. Let's just say if we're trying to mitigate bias or whatnot, what, I guess what state will we build those things in as we're creating?
That's an excellent question. Yeah. So if you do that, I mean, I would do it at several levels. I would do it both at the input, so based on the query, right? We can ask some weird questions, right? What is salary expectation for this applicant, and then something biased maybe. So you need to query the input, and then you also need to check what retrieved. Hold on. Let me answer this with RAG failure.
I mean, Llama Index has that built in, right?
Yeah, there's this nice image that I like to use, right? There's many things that can go wrong. I don't know if I've shown this before. Okay, right, so things can go wrong in many different places, right? My data might be biased, my input might be biased, what I retrieved might not be the right one, the output also might be biased. So there's like 3 points where you have to check for bias. And also there's evaluation metrics that you can add at all 3, especially at the output. The output you need to pass it through some kind of cleanser, checker, verifier. Hey, does this violate any of my policies? And maybe you do that here, right? As we saw here, you have your your bias requirements, and you need to specify those that, hey, if this word is used, you're biased. If you're making discrimination based on whatever, you're biased. If you're giving information about, I don't know, I work in real estate, about fair housing, for example. This is how you need to specify it.
Maybe
Yeah, I didn't give you a perfect answer, but hopefully not.
You know.
Yeah.
You might consider like an anonymization level.
Optimization, yeah, PI, is there any
Fair
PI there?
accounts, ABC 1, 2, 3.
Uh-huh. Yeah, yeah, if you want to take this and maybe government version of this, or, you know,
Oh,
DoD
I see,
version of
like,
this.
Like to remove,
Oh, the names.
like, so,
Like many authors, you know, use their initials when they publish or something, you know, just.
So that,
yeah, but like for salary or for qualifications, is this person senior or mid-level? Like, it's in there.
Use initials, yeah,
You know,
I see what you mean. Okay,
so, at Google, like Gemini has inbuilt input and output controls on the model itself, but then on top of that, you could put in model armor. You could call the model armor API to use your
Cool,
types.
model armor.
Like what it'll do is you could ahead of time tell the model what it should look for to ping for like further censorship.
Okay.
And yeah, so it's basically, to your point, on the input and output from the model.
Yeah, yeah,
It's,
so,
it's a managed service, so you don't have to like.
yeah, so safety, responsible AI filters like dangerous, harassment, yeah, a lot of, all cloud providers have this. Yeah, I work in Azure, so we have something called content filtering for this, yeah. Jailbreaking, we'll talk about that a lot, prompt injection, data loss protection, malicious URL, screening PDFs. Okay, this is cool, like that.
You know, that your example resume is a little simpler because it's a technical resume. So you're asking about programming languages.
Yeah.
You know, it's kind of, we're in a field where, you know, we can enumerate our experience pretty easily. As opposed to something that was like, you know, more of a humanities job, or, you know, I was a manager at Starbucks, and then I was an Uber driver, and then I was, you know, volunteer at the theater.
Yeah.
You know, and then am I a fit for am I a fit now for the manager of some other job? So now that becomes
Subjective or?
it becomes very subjective, and that's where you could, you know, worry about bias and.
Yeah, and that's one of the reasons why I think it's very important to log inputs and outputs. And have a real production use, because then that means that you can use that as a data set for analysis. And so for this higher example, if you have demographic information on applicants, you can then look at your outputs and like, or is there a correlation with actual graphics?
Okay.
They also don't want to end up like Amazon, where they try they did machine learning to identify what candidates were the most successful at Amazon, and they
Hired only men for senior positions, that's who they said they should hire.
But they did a really good job of trying to scrape out all the things that were gendered, but they ended up finding the things like playing lacrosse or rowing, that typically like very male gendered sports were big predictors of success because they're so biased.
So George, I was gonna make a comment, so you talked about the way you made the model output, JSON.
Yeah,
So
yeah.
you wanna take, usually an LLM generates textual, louder text or whatever.
Mhm.
But to use in a workflow or in a general coding sense, you need very structured output. So in this case, you asked it to do JSON,
Mhm.
and I think you may have said it's pretty good at this. I totally disagree. I think
Yeah.
LLMs are famously very, very poor at this. And there's actually companies now that are specialized.
In structured output.
They're selling products to help you get the structured output. In my own experiences, they're really bad at this.
Mm.
And so there's companies that do it at the far end of the output. There's even companies now that take the token level
Cool.
output from LLMs and make it structured there. Because what you often see is you're asking it for a distance,
Yeah.
and it says this distance in miles per hour, and so now you gotta tell it I want miles per hour, and then it a lot of times it adds extra the way a person would answer, right, in language.
Yeah.
But not what you need, which is just a raw number, right? So JSON, telling it to do it in JSON does help for sure.
It might not get the units you're
But there's
saying.
whole industry now
Yeah.
coming out to try to fix that.
It's not scientific, yeah. It's more like English,
I mean, it's meant
language based.
to produce language, right?
Right.
Yeah.
On that point, can you control the temperature?
You can, yeah, when you create
So
the
you
LLM.
turn it down to 0. Have you tried to see if that helps at all with like variation in answers?
Yeah, you get a little more or less consistent, but it's not a guarantee that your output is replicable. Yeah. It's not that easy.
So it was confused about the state. Only if you switch a model from 4 min to 4, will then be state disappear.
Could be, yeah, it's more powerful, yeah. Maybe that it gets it right. Cool. All right, let me cover this last topic and I think we can wrap it up. So what we're gonna do now is you saw it, we had so many questions, right? Hey, you did an okay job to fill in this field, you did an okay job filling this field. Can we intercept as humans and saying, hey, I don't like how you answered this question. Can you emphasize my skills in ABC, right? So that's why we need this human in the loop. So we'll have the same setup. I'll just run this, adding a feedback loop. So the layout here, this is why we're using the workflows now is we'll have the same parser. So we're gonna parse the form. We're gonna ask questions. We're gonna ask questions to our RAG, right? Ask the question, get the event, get the response. But now we'll have this input required event, which is driven by us. And that will do is it will ask us humans, hey, what do you have any feedback for me? Do you have any steps that I could improve on? And then this is us, human response event. We'll get the feedback, and the workflow will say, well, I have feedback. Let me run this loop again. Let me see what you told me, and let me go through each field and see that I answered them based on your feedback. And then ask you again, do you approve? No, what can I improve? This? Okay, repeat. Do you agree? Yes or no? No, improve this. Agree, agree, agree. At some point you're gonna agree, it will exit the loop. That's the new part of this here. And let's see what that looks like in code. So we'll have these two special workflow events, the input and the human response event. The input is it's asking us to input something. And when we when we hit enter, there's a human response event generated. So basically this is like an IO, input output for this workflow. The same event, so parse event, query event, response event, and then feedback event, and then actually, I don't need this. Let's go to the next one because this one, the feedback doesn't do anything with it versus this one. Yeah, so this is the loop, right? So we're going to take the human feedback and I'm going to iterate on this again and again until we have a good satisfactory answer. So what is the difference here? Same setup, parse both PDF and forms, generate the question. How would you answer this question about the candidate? Use our RAG. Now this feedback is this event. Is there any feedback from us? We previously got feedback about how we answer the questions. It might not be relevant to this particular field, but here it is. These are human feedback. That's the only difference. And then here in the end, we need somehow to give LLM an input of, or the LLM to tell us, how does this look? Does it look good? Do you have any feedback for me? And if we do, we need to enter the loop again. So let's look at let's look at a run, I think, and then we can look at the code again. So it's parsing, right? It's trying to fill in the application. It's similar to before: first name, last name, phone, LinkedIn. Okay, so phone not provided. Maybe for that. So it's asking me, how does this look? Give me any feedback you have on any of my answers. If a field is not provided, please say, I don't know, something else. I'm going to say NA here. So now it's going through the loop again. It's parsing it's asking every question again. You can be a little bit smart and you can say, okay, this is about, I don't know, phone. But I don't think I gave it a field. I said, if a field is not provided, please say NA, right? So it has to go through each field. So it's now again asking the RAG for each and single one of them. And if it's there, it'll answer it. There you go. If it's there, it'll answer it. If it's not provided, it will say NA, right? In the course, you see here for portfolio, where's portfolio? Oh, it actually improved the portfolio. When I ran this first, it just gave me, remember, it gave us notable projects. I was going to say, that's a query you can do with that. If I don't have a portfolio, or if I have a website, please mention it. But this is not where you can improve this, right? This is where you'd say, I don't like how this looks, or I don't like how this is written, improve it. This is like your workflow now that you have a human now. Dictate, and let me go to workflow here.
And that's only persisted in this session, right? I mean, it's not like it adds it, but actually, does any of this persist?
I mean, in the end, you can persist this. Yeah, in the end, you can save all this to a
Like
document.
you are trying to use this to regularly have.
Oh, I
people in your
see.
Company update their own, AI generated version of the resume.
Yes,
Could that
that's
basically be fed back in so that it is in there, for the next time they come in and update?
that's a good question. Yeah, so here when I created my human feedback, let me go back to it in code.
So persisting that context.
Yeah. Here. Sorry, no. Come on. The zoom is a bit hard here. Here. Feedback, right? When you receive this feedback special message, the prompt was very simple. But you can do something like retrieve your, like in Python, right? You have like a way of writing Python, right? Based on some standards, right? Maybe you have your own company standards that these are my acronyms. You would import them here, that you receive feedback, make sure that your output, mentions or obliges to this policy.
It seems like this would be a great application of the,
Workflow.
what did you call it? The threading or whatever,
Yeah.
the thing where it collects the
Con-
results. of-
concurrent, parallel workflow.
Yeah. Where if you don't give feedback about a particular problem, or if your general feedback is not general, it only applies to number 2 or something, I would expect it to not change previous answers. Otherwise, I might be playing whack-a-mole. You know what I mean? Like if I give feedback based on one set of answers and then it changes more than what I was giving feedback about, like it improved, it happened. It improved what was it, the portfolio question?
Yeah,
answer.
but yeah.
But it could be that the user liked the output of like a list of projects they've worked on, but then it changed and they have to go read the whole thing every time.
Yeah. So this is why we can be more specific. Let's say portfolio. For project portfolio, please don't use URL. Instead, create a new one based on my resume, emphasizing I don't know. React, or emphasizing my skills. Yeah. All right. LM says the verdict was feedback, so it goes back to the loop. It parses everything. It goes to our RAG, to our resume. What is the answer for first name? What is the answer for last name? So this is an optimization loop, I guess. But you identify first, okay, which part of this process I need to change instead of rewriting it. So let's see. Developed a notable project portfolio using EcoTrack, a full stack application, carbon footprint using React. Okay.
So now change number 4.
Number 4
Sentence.
is look at that, right? Hmm.
So you have to like read the response every time. So I feel like that context, once, like, it should be stationary and like, I guess
Yeah.
this is where the agents come in that say, should I update this one or not? Does this
Exactly.
apply to this or this or this?
Yeah, that's the room for improvement. That's the room for
It's like
improvement.
you have a.
It looks great.
The whole thing in LM asks to rechange one function, it might rewrite the whole thing, you have the other stuff.
Yeah. But that's because we're literally generating it from scratch every single time. Yeah. So in the end, I said it looks great. Where do you go? And so let me write it one more time. And then it looks, I'll just say it looks fine. It will say, okay, the verdict was okay, agent complete, here's your result, and exits the loop, you know? So it exits this loop here. Otherwise, you'll generate these questions every single time. Yep. Yeah.
So I'm curious, George, to hear your thoughts. I actually like think about agentic workflows like this. At this point, do you think we should think about it more like workflow orchestration, like something like Airflow, where we have tasks that we want to do with some, intelligence as we do them, maybe even, or is this, should we like anthropomorphize the models and systems a little bit more, think of it more like having a, intern that we give a task to?
I would say it boils down to the. So I appreciate the building blocks here, right? We didn't have them before. Before we was input output, and there was no memory, right? You had to have your own memory. So I like the building blocks. I like the logic here, and I like this persistent memory. The reasoning capabilities, we're not there yet, right? Maybe you can use a more developed LLM, like the newest one, or a reasoning model, but those themselves take a while to get an answer. And who knows, maybe they have a workflow underneath them that goes to town, gives you an answer. Or it's a collection of LLMs that asks 3. But I don't know, to me the framework is more interesting than, to me, I see that as a first step in many others that you also introduced llama parse, right? So maybe that's something we can take from here, that you have structured PDFs to text, and also this logic now, this workflow logic. So you have some building blocks so you can build something out of it. Now the quality, it's not the best, but if it's something as simple as, hey, I have tedious form input, can you automate that? Yes. If I need to apply for jobs, can I have this as a project tomorrow? Like, no. I mean, there are other products that I've seen that does this. You give them your resume, you give them a website, and it tries to fill it in, or it tries to generate your resume and your cover letter, but it does an okay job. Yeah. I don't know if that's a good answer. I'm curious to hear, what you guys think as well. There's one more topic that I didn't get to cover. It's about voice, but it's fine. We can skip that.
Don't think we're at the point yet where these things are, fire and forget, right?
Mhm.
Can they, like, if you have to do 20 of these, can it get your name, your address, your, all that stuff, and then fill in something there and go, oh yeah, I gotta change this. And maybe you still have to do all 20, look at all 20, but maybe you don't have to worry so much about
filling in, type, getting all this stuff done.
Yeah.
Like it's like,
Yeah,
it's certainly an assist, right? And probably if you had to do this by hand, or you had to do it with something that could do like this, you probably could save
Yeah.
yourself like half the time.
maybe in the end of the workflow, you say, okay, generate a Word document, which is the filled version of this PDF. And then you review it. You say, okay, name looks great. Okay, I would add this. I would edit this. So now you have 5 applications, you know.
Yeah, like I said, I don't think you're at the point where it's like, hey, you know what, just like, go ahead and send this in, right? This, you know, just let it go. And then, but there, I don't
Yeah.
think we're there at all, but on any of this stuff.
No. It's like self-driving cars. No, you need your hands on the wheel. Yeah. Cool. So yeah, I hope you like that. And then next week, is it next week? To get ready. David is gonna present, Will is gonna present. I'll present for a little bit. I've taken too much mic time, but mostly David and then Will and then I will do custom applications. So David has a cool custom application, Will has a cool one. I have some ideas I need to work on mine. But whatever we learn, okay, something, you know, applicable, something okay, something that doesn't just produces events, but something like this, resume, what's the weather, what's the traffic, you know, something applicable.
Are the previous sessions recorded?
Yes, all of them. If you go to Meetup, it's there's a link here that says this one here.
Anybody turn else?
Text. The recordings?
Transcript?
YouTube. Throw it in for you, Gemini.
Or Notebook LM?
Yeah.
Cool. So yeah, that's what we have. And then I'll see what else we have on my index, because I think we're wrapping up on my index, but that's about it. So yeah, I'll stop the recording here. Any questions on Zoom or in person? Let me know. Okay. Thank you, Mike. Okay, I'll stop sharing and I'll post the recording after this. Thank you so much. All right.